8 is all about three-dimensional shapes, so we're going to start with polyhedrons. Now, polyhedrons is a three-dimensional shapes whose surfaces are polygons. Now, a polygon is something that's connected with lines. So here are some three-dimensional shapes that we have. We have a rectangular prism. You have a pyramid, a cone, and like a cube. So these are the shapes that we're going to be talking about, some of which today, and then some on Monday. So each polygon is called a face. An edge is a segment that is formed by the two faces, and a vertex is a point where the three intersect. So if I think about this Kleenex box, the top, bottom, and sides are all called faces. These lines where two faces come together are called edges, and then the corners of the box are your vertices. Does that make sense? Okay. I always like to use the Kleenex box. It's easy to see that big a visual. Here's a formula that you need to know. It is not given to you on a test or quiz or anything. This is one that you have to memorize, but it's called Euler's formula. The faces plus the vertices equals the edges plus 2. So a lot of people will say F plus V equals E plus 2. And that's how you find out different pieces that you need. So for example, well, we're going to find those missing pieces in a minute. But here are your 5 types of regular polygons. Do not draw these pictures unless you're really artistic, but write down those 5 types of regular polygons. So regular polygons have congruent faces, and all the angles are the same, all the side lengths are the same. It's kind of like an equilateral triangle, but it's equilateral three-dimensional spaces. The number that's in parentheses is how many sides that you have, how many faces that you have. Now the pictures go along with each of these. So again, these are your 5 regular polygons. This is a list that you need to memorize. Spelling is pretty important. You know, as long as we can phonics it out, it should be the same thing. So the first one we have is a tetrahedron. So this first shape is a tetrahedron. It's made up of what kind of shapes? Triangles. There are 4 triangles put together that make a tetrahedron, and all 4 of those triangles are equilateral triangles. So they have the same side lengths and same angles. Option 2, the second one, is a hexahedron, also known as a cube, and it has 6 square faces. Octahedron has 8 sides, and all sides of those are equilateral triangles, as you can see in the picture. We have a dodecahedron. Kind of looks like a soccer ball to me, but all the 12 faces are pentagons. They got 5 sides. So all the side lengths are the same. All the angles have the same measure. And an icosahedron is how you say this last one. It has 20 equilateral triangles. Has any of you seen those Moravian stars come out at Christmas? Y'all seen those before on people's porches and stuff? This is the base of a Moravian star. So if you wanted to build one yourself, you can actually look at directions online, or they have templates. But the base of it is an icosahedron, and then they just draw pyramids that hook on to each part. So I know I have one of these at home, except I haven't put it on my porch because every time I start to hang it up, a piece falls off, and then I try to put that piece on and 3 more fall off, and it's just really not fun. But when I was in 6th grade, I actually made one of these. It was kind of funny. We had to make a 3-dimensional shape, and I chose the hardest one for some unknown reason. It was not pretty, but it was pink. So, you know, just stories about Miss Cook's life. But anyway, in case you wanted to make a Moravian star, you make an icosahedron, and then you attach your points to it to make it like a star. All right, let's use these last 2 slides to fill in this information using Euler's formula to find our missing information. So write these down, and then we will do them together. While you're writing that down, I'm going to pass out this note sheet because we're going to use it on the next few problems. But that might be it. Now, Euler's formula. Look back at the very beginning of your notes that you took. Euler's formula says what? Good. Bases plus vertices equals edges plus 2. So in this first one, we have pretty much all the information. The face is F. That's what we're missing. The vertices is 9. We have 15 edges plus 2. So F plus V equals E plus 2. Solve that equation for F. F plus 9 equals 17 minus 9. So F is 8. Pretty simple equation there to solve, huh? All right, let's look at number 2. Solve it the same way. F plus V. So we get 8 plus 12 equals E plus 2. What 8 and 12 make? 20. Minus 2, and E is 18. Sometimes, though, we're not given a simple information like those first 2 problems. Sometimes we're given a problem like this, and it says a polyhedron with 8 triangular faces. Well, we have to imagine what that looks like. Now, good thing is on your homework, you could also just type that definition into your phone or into your Chromebook and type in polyhedron with 8 triangular faces. And it will show a picture, because we actually have a picture of a polyhedron with 8 triangular faces. Da-da-da, right? Our octahedron has 8 triangular faces. So what we wanted to find on this one is we wanted to find the number of edges. So we could do this 2 different ways. You could actually find the number of faces and vertices, or you could just count the number of edges. So I'm going to do it faces and vertices. Well, it said it had 8 triangular faces, so faces would be 8. Vertices you can count pretty easily because those are the points. So we have 4 triangles at the top and 4 triangles at the bottom, right, for that to fit together. So I have a vertex up here. I'm going to use yellow so we can see. Up here at the top, and there's one here. How many vertices would be around the middle? 4. 1, 2, 3, 4. So total we have 6. So faces plus vertices equals edges plus 2. 8 plus 6 is? So E would be 12. And let's just confirm that by counting that in our picture. So we have 1, 2, 3, 4 edges for the bottom, 1, 2, 3, 4 edges for the top, and 1, 2, 3, 4 edges for around where they connect. So 4 plus 4 plus 4 is 12. So there we go. So if it gives you a description, the easiest thing that you can do is think about what a picture would look like, or Google that definition to see a picture. And so that way you can find your missing part that you need. So that one needed 12 edges. Does that make sense? Okay, next thing on our list is a cross section, and that is on your handout. So everybody look at your handout that you got. Now, a cross section is the intersection of a solid and a plane. You can think about a cross section as a very thin slice of the solid. Also, when you do cross sections, your answer will be a two-dimensional figure, okay? Like circle, rectangle, parallelogram, square, whatever. So, what happens with cross sections is, imagine like I have this Kleenex box, and then I take a saw or something and I cut it in half, and then I turn it towards you and you tell me what shape you see. So that's basically the same as picture A. If I put in that cross section in there, what shape would it turn into? What two-dimensional shape would you see? A square. So you don't want to say cube because that's three-dimensional. So think two-dimensional. All right, what about B? What would you see? Triangle. Good. Another way of thinking about these is also thinking about a stamp. Imagine that this was a big stamp and I went boop like that on my paper. What shape would I see? All right, your next two questions are multiple choice. It says draw a figure that has the same cross section as the sphere. Now notice how this one is crossed. It's crossed at a diagonal. So you cut it at a diagonal, you stick it in a stamp, and you stamp it on the paper. What shape would it make if you stamped it on a flat sheet of paper? C is correct. A lot of people want to say D, and that may be what it looks like to you, but if you stamp it on the paper, it's going to look like C. All right, this one, the shape at the right was created by rotating. Now, what do you do when you rotate something? You spin it around. So we're going to spin these around, and which of the following would create this shape? Which one? The A triangle or C? I've heard C. Which? C is correct on this one too. C is going to make this bottom part and this top part. And imagine if you traced it along the outer sides, you would get the same picture of C. So it's kind of like if you're holding it to a string. Have y'all ever had that toy before? Probably not. You hold it to a string and you pull it out and it's like, yeah, you know what I'm talking about. And then it spins. You're like, phew, that's what shape it would make. Does that make sense? All right, great. That is all the information that I have about polyhedrons. So that is part of your homework, is just matching these up, looking at cross sections, using Euler's formula to figure out what you're missing, and then knowing these 5 shapes. So now we're going to move on to prisms and cylinders. So flip over your sheet on the back and you actually have some things there. And we're going to put some definitions and things with them. So this is on your note sheet. Flip it on the back. You are missing this information here by Prism and those formulas. So write those formulas down. All the formulas that you cover, we're actually going to look at 3 formulas for each shape. So there are a lot of formulas, so you might want to do index cards to help you study and review and memorize them. I actually have 1 index card with all my formulas on it, so that way I don't forget. From what I've heard this morning, there's not. We're almost done with our pumpkin. We're finishing him up. Today we're talking about prisms and cylinders, and then on Monday we're going to talk about pyramids and cones. All right, so we have 3 different formulas that we need to know for prisms. The first one, LA, is lateral area. Now let me tell you what that means, although it says it up here. It's the sum of the area of the faces. Imagine this room as being our 3-dimensional shape. If you wanted to paint this room, you would paint these walls around the outside, right? Would you paint the ceiling or the floor? You might paint the ceiling, but if you're going to go buy, let's say, blue paint, would you really paint the ceiling and the floor? You're just going to paint the walls. That's what lateral area is. Lateral area is like we're painting this room, we're painting the walls. Surface area is when we paint the walls, the ceiling, and the floor. So surface area is all surfaces. Lateral area is just the faces. So when you look at these shapes here, the lateral area would be the front, the side, the back, and this other side, not the top or the bottom. So with a prism, this is the definition, and these are some things that you need to know. A prism is a polyhedron with 2 congruent faces, which are called bases. The bases are also always parallel from each other. So they are congruent and parallel. Now, when you have a box, a cube, a rectangular prism, whatever it looks like it's sitting on is the base. So for this example, this part down here would be your base. Okay? So when you have a prism, whatever it's sitting on is your base. Now when you have a triangular prism though, you have to remember that it's the congruent bases that are parallel to each other. So in this one, can I use this rectangle right here as my base? No, because there's not another rectangle that is parallel to that one. Your base is going to be this triangle shape here. This is your base, and this is your base. So if it's a triangular prism, the triangles are the base. So it may not be sitting on the base when you see the picture. These are the formulas that you need to know. So lateral area is the perimeter of the base times the height, so pH. Surface area is pH, which is our lateral area, plus 2b, where 2 is 2 bases, and b is the area of that base. Now, if your base is a rectangle, how do you find area of a rectangle? How do you find area of a rectangle? Length times width. I figured I was talking too much and y'all had zoned out for a second. So area of a rectangle, you might want to write this down just in case, equals length times width. Now, if we're talking about a triangular prism, we have to talk about the area of a triangle. What's the area of a triangle? Good. Base times height over 2 is usually what we say, but B and H here are a different B and H that are over here. It's the area of a triangle. So this will help you find your capital B or your base. Now, volume is BH. Now, you probably know that if you have a cube or rectangular prism, you do the length times the width times the height. I know that's what my daughter did last year and this year to find the volume of a prism. You times those three numbers together. Well, B, area of the base, is the length and width if it is a rectangle, and then height is your H, so it's height from base to base. Next, I was like, where? I thought you meant the formula. That's what I was looking at. All right, so this height right here, you might want to add this note. H is the height from base to base. So it's from those congruent face to the congruent face. I didn't want you to have to draw these three-dimensional figures, so I'm passing out these extra notes for you with the figures drawn, so that way you don't have to draw them, because I know that these can be hard to draw, especially the triangular ones. Okay, so our first problem here is a rectangular prism, right? So the first thing that I like to do is I like to kind of shade in the base. What numbers are part of our base? 5 and 8. So this is our base. Now, if we go through our formulas, lateral area is pH. P stands for what? Perimeter of the base. A lot of times I will write to the side what the perimeter is. So the perimeter is a rectangle. And what do we know about a rectangle? Opposite sides are congruent. So if I wanted to find the perimeter of this base, I would say 5 plus 8 plus 5 plus 8. I would add up all four sides. So what's 5 plus 8 plus 5 plus 8? So for LA, I would have 26 times H. Now, H is the height from base to base. So my height is 3. So this number over here is H, 3. All right, grab those calculators. Let's multiply those out. I'm glad somebody has their calculator out already. 78. Now, this is LA, lateral area. So what should be the units on this? Inches squared. Area is always squared. All right, next we have surface area. The formula for surface area is pH plus 2b. Now, the good news is we already know what pH is. pH is our lateral area that we just got from the previous problem. So pH is 78 plus 2 times B. Now, we need to figure out what B is. So if you look back on your other sheet, capital B is the area of the base. Well, the shape of the base is a rectangle. Area is length times width. So 5 times 8, or 40. So 78 plus 2 times 40 is So just use your calculator, type it in, and then don't forget units. It would be inches squared because we're still talking about area. Last, we have volume. The equation for volume is BH. Well, we already found B before to be 40 from the previous problem. And H from the lateral area is overall height, which is 3. What's 40 times 3? 120 inches cubed. And that's what you need to find for your problem. So if anybody wants to be TikTok famous or YouTube famous, you could do things like this because you might want to paint a room for YouTube. So you need to know, or, for your normal life. So if you find lateral area, that will tell you how much paint that you need, how much paint you need to buy, so you don't have to overbuy or underbuy and then have to go back to the store and waste money. If you wanted to paint the whole room, ceiling and floors too, you can find surface area. If you want to fill the room with popcorn and jump in it, then you would find the volume. That's what volume is. All right, let's do our next one, which is a what shape? Because you can paint way cheaper than you can hire somebody to do it. Way cheaper. You get a ladder. Roll it. That doesn't surprise me. All right. So in this shape, it's a triangular pyramid. So the bases are the triangles. So don't forget that when you see it because somebody is bound to mess it up. So this triangle here is your base. If you need to, draw that triangle to the side. This would be 15. This would be 8. That might be a good idea to do, that is your base. Your base is the triangle. What is H, the overall height of this prism? It is this 8 over here to the side. The distance from base to base is your height. So now we're ready to use our formulas. Lateral area is pH. Well, what does P stand for? Perimeter of the base. Do we have all 3 sides of this triangle? No, we do not. So what do we have to do? Pythagorean theorem. 8 squared plus 15 squared equals what squared? So grab those handy dandy calculators and calculate what x is. Good, and then square root it and you get 17. This is one of those Pythagorean triples. There are 3 whole numbers that work in the Pythagorean theorem. So 8, 15, 17 are our numbers. So the perimeter of this base is 8 plus 15 plus 17, which gives us 40. A lot of times when you see these triangular prisms, you're going to have to do Pythagorean theorem. All right, so P is 40 and H is 8. And it's the 8 here that's on the side from base to base. So 40 times 8 is 320. Don't forget units. This would be meters squared. All right, next we will find our surface area, pH plus 2B. Now remember, we know pH from the previous problem. pH is 320 plus 2 times B. Now, B we don't know, so I'm going to go back up here and find it because B is the area of that triangular base. So we said to find the area of the triangle, it's base times height divided by 2, or 1/2 times base times height. Now when you look at a triangle, the base and the height are the parts that make up the right angle. So the base would be 8 and the height would be 15. So the legs of the right triangle are the base and height, which makes it really easy for us. So let's see, 1/2 times 8 times 15 is 60. I believe I heard somebody say that a while ago. I just want to make sure everybody got all the stuff. So 60 would go in here for B in our formula. Then just type that in your handy dandy calculator. 320 plus 2 times 60 is 440 meters squared. Last on our list is volume. Volume is BH. B is the area of the base, so 60. H is the height of the prism from triangle to triangle, which would be 8. So 60 times 8, 480. But now we're talking about volume, so it is meters cubed. Because when we do the area of our base, the area is in squared, and then you multiply again, so it makes it cubed. All right, I want you guys to try number 3. You guys try it. Maybe we'll randomly call some people up to put some things on the board. Y'all stayed up too late last night. Trick-or-treating, scaring kids, egging houses, rolling yards. Just kidding. Huh? Oh, okay, yeah. Sorry, I stuffed them down in there. There you go. Need some more? Okay. All right, try number 3. Try number 3. Use your formulas. No, the base would be the triangles. So remember, if it's written with triangles, the base is the triangles. Mm-hmm. 50. Mm-hmm. Mm-hmm. That's right. I'm glad I'm hearing y'all have some conversations here. But the triangle is the base. When you have triangular prisms, remember the definition of a prism is 2 congruent parallel bases. So the triangle is the base, not the 50. What's 50? The height. All right, so while you're writing it, does anybody want to put it on the board? I'll put it up this time. The good news is we've seen this triangle before, right? There's more in the pencil box back there. There's even mechanical ones. Yeah, if you notice the triangle base should be the exact same triangle as you had before, just the legs are switched. Is that going to change your perimeter? Is that going to change your Pythagorean theorem? Is that going to change your area? No. So it's all the same as the last problem because it's all the same numbers. You may notice that also on your homework too, that you might do Pythagorean theorem one time and already get the measurement, then you just use that same measurement again. Do you know the area and circumference of a circle? Then yes. All right, but this is how you do prism. So remember, if you see a triangular prism, the triangles are the base. You might want to write yourself a big note on your paper because when you go back and look at this, Sunday night at 9 o'clock when y'all decide to do your homework, because we know we don't do it before then, you might want to write a note and say, triangles are the bases, okay? And the height, although we wrote this down before, you could write it down again. The height is the distance between the triangles, or the length between the triangles. That's the height of the prism. 60 is the area of the base. It's the same base as the one in this problem, so that's where the 60 came from. It's 1/2 the base times the height. When you have a right triangle, the legs are your base and height. So it's just those two flipped, which would still give you the exact same equation. In a couple hours. All right, let's talk about cylinders. Cylinders are the same thing as prisms. The only difference is instead of the top and bottom being a rectangle or a square or a triangle, the top and bottom are now circles, right? That's what a cylinder is. It's got circles on the top and bottom, just like my coffee cup over here. So this would be, although it's a little slanted, but this would basically be a cylinder. Circle on top, circle on bottom, and it's wound together. You can actually use the same formulas for prism and cylinder. The only difference is your bases are no longer rectangles or triangles, they're now circles. So instead of talking about perimeter, we talk about, what's the same as perimeter in a circle? Take your finger around the jar. Circumference equals 2 pi r. So don't write this down yet, but this is exactly what you do for a cylinder. You replace all these p's with circumference, which would be 2 pi r, and you place all the b's with area of a circle. For area, you multiply r squared times that number, pi. So the formulas have a lot of pi's and 2 r's in them, but it's because you're replacing b with the circumference, or b with the area, pi r squared, and p with the circumference, 2 pi r. So they're the exact same formulas you had for prism, you're just replacing. We are going to leave it in terms of pi because it makes your life way easier. Now, with a cylinder, you have R and H in there. Those are your only variables that you have. What does R stand for? Radius, and H stands for height. So this is R, and this is H. So H, again, is the overall height from base to base. So from circle to circle. R is the radius of the circle. Do what? Yeah. Well, if it doesn't, then it will give you like the volume or area, and you have to solve for height. But I kind of took those out. You're welcome. I had to find 2 more days to give y'all check-in tests, so I had to cut 2 things out. Then you have to retake the class. We don't offer summer school to 10th graders. No, not freshmen either. Just sophomores and juniors. No, juniors and seniors. Is it up? Its priority goes to juniors and seniors. If there's room, they fill in. However, summer school is for the whole county. It's not per school. All right, so here we go. Cylinder. Let's do our lateral area. Let's go back to this example here. We know everything in it in list. This is R. R is 3, so what is 6? Good. So lateral area is 2 pi RH, or 2 pi times 3 times 6. When you grab your calculators, you just multiply those numbers together. Do not type in the pi button. You type in 2 times 3 times 6. Leave your answers in terms of pi. 2 times 3 times 6 is 36 pi. Good. Don't forget units, meters squared. Now we use our surface area formula to find the surface area. But don't forget, just like our prisms, this first part, 2 pi RH, is what we got out for lateral area. So you could replace that part with 36 pi plus 2 pi times 3 squared. So it's 36 pi plus, and if you wanted to multiply those out, 2 times 3 squared is 18 pi, and then add those together. So we get 54 pi meters squared. That would be our surface area. You can type it all in together, doing 36 plus 2 times 3 squared, and it would give you 54 really easily. All right, the last thing we have is volume. Volume is pi r squared h. So pi times 3 squared times h is 6. So in your calculator, just do 3 squared times 6. You get 54. Don't forget the pi, and it would be meters cubed. Now, on your homework, you are not allowed to just write the answer. You have to write some things with it. So if you were doing this problem on homework, I would expect to see, oops, I was going to do more of a highlighter one, but V equals, and then this right here. So SA, and then you could write this, and then the answer. LA, this, and answer. Does that make sense? Okay. So make sure you have some work and then the answer. If you just write down the number, maybe you copied somebody's. So I don't want to see any of that. All right, let's do our last problem. Now, our last problem doesn't give us the radius. It gives us the, so what's the radius? Good. So R equals 5, and H would equal 2. So LA, perimeter times height, or circumference times height. Take your finger around the jar, circumference equals 2 pi r. And then times it by height. So in your calculator, you're just typing in 2 times 5 times 2, which is 20. Don't forget to put on pi and then units. Good. Surface area is your lateral area plus twice the area of the base. So it'd be twice. For area, you multiply r squared times that number pi. Now, don't forget there are some similarities. LA, which is the first part there, is 20 pi. And then we add 2 pi r squared. So in your calculator, 2 times 5 squared is 50. And then add those two together. 20 and 50 make 70 pi units. Good. And last, volume. It's area of the base times the height. For area, you multiply r squared times that number pi. And now we times it by h for volume. So it's pi times 5 squared times 2, which we actually did right up here, right? It's kind of neat. It'd be 50 pi. You might see that especially with cylinders and things with circles, that your surface area is more than your volume, and that is okay. All right, your homework is this worksheet. It was just on one page front and back, but these problems were hard to see, so I made them bigger. There's not as many problems there because there's so many drawings and things. But if you look at the 2 separate pages, most of that stuff is what we did at the beginning of class with polyhedrons, besides the very last problem. And then these here say find the lateral area, the surface area, and the volume. So you have to find 3 things for the 6 pictures on the front. Again, I went ahead and put on the board that this wasn't due until Tuesday because we have a shortened class today. So you have some extra time to do it, but you could definitely get it done this weekend. Yes, you can. All right, just a reminder too, this is mainly for video purposes. This is a very short unit with our quiz on Tuesday and test on Thursday.